Hi everyone, welcome back to the channel. My name is Priyansh Agarwal, and in this video, let me tell you about my course called TLE Eliminators that I've been running from April 2021. So it's been 3 years since I've been running that course. We have taught more than 5,500 programmers through that course already. Now this entire course, is divided into 4 levels. So for somebody who is at a particular level in their competitive programming journey, they can choose to join a level and learn only those relevant topics. So first of all, you get live classes on all of these topics, right? Every single week, we have around 1 to 2 live theory classes, and we teach you all of these topics in a very structured manner. Secondly, we provide you with curated practice problems on all of these topics that we've taught you. For example, if I teach you dynamic programming for maybe 3 weeks, then in these 3 weeks, I am going to give you 2 to 3 problems every single day. Now, in case you're stuck on any practice problem from the course, you get dedicated video solution where we talk about the exact intuition involved. How do you think? Apart from this, if you're stuck on any practice problem from or outside the course, we provide you with instant doubt support. Now, what happens in doubt support is that we have a team of around 30 to 40 experienced competitive programming mentors. These mentors are already experts and candidate masters on code forces, and they help you solve these problems in which you're stuck. Like you could come up with a debugging problem, you could come up with a problem in which you require some hints, and overall, you get to learn a lot from the experience of these mentors. And apart from that, there are other pretty cool features. You can go and check out our website to explore them. One thing that I want to mention is that TLE Eliminators is a live course, right? So every 3 months we launch one single batch, and in one single batch we run all of these level 1, 2, 3, 4 parallelly. So you can go onto our website and check out when is the next course coming up, and if you're interested, you can sign up for that.
So this is the first problem of today's Dev 2, and in this problem we're given that chef likes to create disturbance in numbers. In other words, he doesn't like numbers when they are in their right positions. So now he has a position permutation P of size n, and in one operation he can swap any two adjacent elements. Now his goal is to alter the permutation in such a way that Pi is not equals to I satisfies for every I between 1 and n. So we have to find the minimum number of operations required to achieve this goal. So there's a permutation, and if I is equals to Pi, this means there is a 3 here and a 5 here. So for these positions, let's say there's a 6 here. For these positions, Pi is equals to I, right? And we don't want this. In one operation, we can swap two numbers. So we have to find the minimum number of operations that are required. So first of all, let's call these positions as, let's say these are some special positions which have Pi equals to I. So if there are two of these positions like this, we can get them like in one swap, we can get 6 here and 5 here. So neither this will be special nor this will be special, right? Yes, no? In just one move, I can get both of these places having, like, for both of these places, this will be true in just one move. But for this, I'll have to do this kind of operation. Like, even though this is not a special position, it doesn't have Pi equals to I. Let's say there is a 1 or there is a 4, anything. I have to do operation like this, or I can do like this also, anyway. But the thing is, if I do like this also, after this move, it's also guaranteed that for both of these places, Pi won't be equals to I. Why? Because if 3 is here, and this means that 3 is not here, 3 is here. So if I swap this, something which is not 3 will come to this third place. And if I already know that there's a 3 here, and this is the third position, and the second position, I'll have 3. So for both places, Pi won't be equals to I. Is it making sense? Yes, no? Like anyone having any doubt in this? Like anyone having hard time to understand that? Okay, it makes sense. So basically my point is, if you encounter special positions, that is like, let's iterate from left to right. And if you encounter a position for which pi is equals to I, then first of all mark it as special and just move ahead. Otherwise, if let's say you encounter another pi equals to I special position, check whether the previous one was also a special. If it was a special, then you don't have to add one, like you don't have to do an extra operation for this. You can just do operation like this. Otherwise, if there was no special position previous to this, you'll have to do one operation for this thing. So mark it as special. Keep doing this, and eventually, if let's say even though there was a special position before this, and you are already doing one operation for this, you don't have to do one operation for this. You can just include this one in this. Is it making sense? Like simply put together, if there, let's say there are 5 positions, 5 special positions occurring together, the total number of operations that you require for this is 5 divided by 3 seal. If there is just one occurring alone, then it is 1, not 5 by 3, 5 by 2. Like 2 can be done together, and this one you'll have to do separately. So if just 1, so 1 divided by 2. So either you can look at it like this, or simply just go from left to right. If you encounter a special position that is having pi equals to I, just add 1 to your answer and move ahead. If you encounter a pi equals to I, then like for every time, just check the previous. If the previous position was also special and you were adding 1 for it, then you don't need to add 1 for it, the current position. Otherwise, if there is no previous special positions before it, or even though if it is, you didn't added 1 at that point. Let's say this was the case. This was special, this is special, this is special. This is 2, 3, 4, and this is 5. So you encountered a special positions, you added 1 to your answer, then you came to 3, this is a special position, but the previous is also special, and you have already added 1, so don't do anything in this. Then you came to 4, you added 1 to your answer. Why? Because of the previous, even though it's special, you didn't add 1. And then you came to 5, the previous special, and you have added 1, so your total answer is 2. Is it clear? Yes, no? Okay, what is the doubt? Someone said no. Okay, once again, see, you just, if there is a special position, that means their pi is equals to I, you can swap this in either left or right. After, if you swap it left with number, both will have like pi not equals to I. If you swap it with right, both will have pi not equals to I. But the thing is, you don't know where to swap it, so just add, like, but you know you'll have to swap it, so just add 1 to your answer. Now once you go ahead, you see that okay, this is also a special position, and you see that the previous one is already getting swapped, so you can combine these two. So just one operation, don't add 1 for it. But let's say you again go ahead and you encounter 4. Now this is a special position, and you cannot combine this 4 with 3 because you didn't add 1 for 3. So add 1 for 4 now. Now after 4, let's say there was a 6 here, there was a 7 here, and a 6 here. So 7 is not a special position. For 6, you encounter that this is a special position, and before it there is no special, so you cannot combine 6 with this, so you'll have to add 1. So like this, just add 1 for those which cannot be combined with previous special number. Is it clear? Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken n as input. Each test case I'm taking n as input, then I'm taking array A as input. Then initially my answer is 0, and check is basically whether or not the previous is a special, and I have added 1 for it. So I'm going from left to right. If my current position is a special position, that is at ith, this I is starting from 0. So that's why if a of I is equals to I plus 1, then I'm adding 1 to my answer if the previous position is not like if check is not 1. If check will be 1 if the previous place is a special position and I have added 1 for it. So if check is 0, I'll add 1, and if check is 0, then I would have added 1 here, so I'm making my check 1. Otherwise, I'm making my check 0. This is for the case when the current place is a special position. If the current place is not a special position, for the next number, I need to mark check as 0, irrespective of what initially check was, if it was 0 or 1. Finally, I can print my answer. Is it clear? What about others? Okay, so let's go to the next problem. So in the next problem, we are given that we have Erin, Mikasa, and Amin are playing a game with an array A of length n to get freedom. And Erin can select any indices I and j such that I is more than equals to 1, j is more than I, and j is less than or equals to n. Then let A, B, and C denote the points of Erin, Mikasa, and Amin respectively, where A is basically AI minus AJ, B is AI plus AJ, and C is AI multiplied by AJ. Now Erin, Mikasa, and Amin will get freedom if the values of A, B, and C form an arithmetic progression. So we need to count how many such pairs I and J there are such that they get freedom. Okay. Okay, somebody just asked that why we are assigning check is 0 after every. See, simply here you are asking about this because this, if AI is not equals to I plus 1, this simply means that the current ith position is not a special position. So for the next, I need to make sure that even if check is 1, I am overwriting it as 0. Is it making sense? Like for the next position, you don't have any previous special position that you can swap this with. So that's why we are sending 0. Okay, so now coming back to this. So basically we are given that there is an array A and we have to count the pairs such that I is more than equals to 1, is less than j, this is what, right? And we are given that A, B, and C should be form a arithmetic progression. So basically what is arithmetic progression? That the difference between these two is same as the difference between these two. So B minus A should be C minus B, right? So 2B, like just bring this here and bring this here. So 2B should be C plus A. So let's write 2B. This is 2 times AI plus 2 times AJ and C plus A. C is AI into AJ plus AI minus AJ. Then if you bring AI this side and AJ also this side, you'll get AI into AJ is equals to AI plus 3AJ. So you need to find I and J's. I should be less than J such that this is valid. Now let's say, let's write this equation. So let's say AI is X and AJ is Y. So you basically have this equation. Now you can apply binaries. See, first of all, you cannot brute force. Like you might think that let's try to fit values of X and accordingly find values of Y. And we'll already in like using a map, we can make a count how many times each value occurs. And for every value of x, we can count how many times, like if I have y or not. But this will give you TLE. So what we can do is you can apply binary search, like maybe like somebody said in the chat only that apply binary search. But okay, map solution is also passing. Like just count. The solution is n log n. So yep, that should also pass. But the best thing is that if you look at this equation, like I just saw this equation and this has a peculiar form. If you know, this is a hyperbola. So I just copied this equation and pasted it like in any, like I wanted to see what this graph actually looks like. That is xy equals to x plus 3y. So see, both in my array A, if you look at the problem, array A values are more than or equals to 1. So in this part, my x is negative. In this part, my y is negative. So all of these are like you can just ignore these values, right? Now, looking at this part, you can only have integers. Like array A is only having integers. So we can clearly see that one is 4 comma 4 and the another one is when x is 6, y is 2. Other than these, you will never get integers because x equals to 1 is a asymptote. What is asymptote? It's a tangent to this hyperbola at infinity. Like I know this is too much maths. You don't require to know this. Just know that these are the only two integer points. Basically, y equals to 3 and x equals to 1 are asymptotes for this function. Even if I go at infinity, then also these two will never touch. Like they will be tangent, not seek. Like they will never touch actually. Tangents at infinity are called asymptotes. So this 4 comma 4 and 6 comma 2 are two valid points. So only two valid points for this is 4 comma x comma y can be either 4 comma 4 or it can be 6 comma 2. So you just need to count how many 4 comma 4 you can get such that I is less than j. Like ai is also 4, aj is also 4. And how many I less than j positions are there such that ai is 6, aj is 2. So now this is a very simple. What you can do, just like whenever you get 4, just count how many times before you have got 4. Because all the positions before this can act as I and this will act as j. And whenever you get a 2, just count how many times before you have received 6. All those positions will work as I and this will work as j. So for every 2 and 4, add these to your answer. Is it clear? Yes, no. The 4, 4 is also from graph. This thing, this point. You can see that when x is 4, y is also 4. Like, by the way, you can directly put it like replace 4 comma 4. So 4, 4, 16. 4 plus 3 times 4, also 16. And 6 comma 2 is like that also. X is 6, y is 2. So 6 2 is 12. 6 plus 3 times 2, 12. So let me show you the implementation. So in this, I have first taken n as input. Then this is my count of 4, count of 6, and answer. By the way, you don't need these two variables as long, but you need answer to be long. Then I am taking my, like I haven't taken my, like I'm not declaring any array. I'm just taking this value as like input and I'm seeing that if x is 4, just add the previous count of 4. If x is 2, just add like the count of 6 that you have up till now. Finally, increment these two values, count 6 and count 4. And then we can print our answer. Is it clear? Yes, no. Or is someone having any doubt in this? Anyone having any doubt? Okay, so let's go to the next problem. So this is the next problem. So in this problem, we are given that we have a string s of length n consisting of lowercase English alphabets, and in one operation we can choose any 3 consecutive characters in s and apply a circular shift. So this is example of circular shift. I'll explain it in a moment. So finally we need to find the total number of distinct strings that are possible if we apply the mentioned operation exactly once. So you cannot apply it 0 times, you cannot apply it more than once, you need to apply it exactly once. So what is a circular operation? Circular shift is, suppose this is the string, suppose this is the string, and you apply circular shift on these 3. So this will come here, this will come here, and this will go here. So this is a circular shift. So we need to count how many different strings will be there if I apply this operation exactly once. By the way, what is the maximum number of different strings that I can get? Any idea? If this is the string, let's say the size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the maximum number of different strings I can get? Okay, perfect. Someone is saying size minus 3. Actually, it is, if n is the size, it would be n minus 2. Why? Because either you can shift, like either you can apply operation here or here or here. Eventually, like you can apply your last operation here, right? So you can see that there are basically n minus 2 valid positions to apply operation on, right? So if there are n minus 2 valid positions to apply operation on, you'll get at max n minus 2 valid strings. I think this is it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So n minus 2. Is it making sense? Now, if this is the total number, like first of all, if let's say I have A, B, C, all 3 are different. Then if I apply a cyclic shift, like in this kind of substring, like this thing, I'll get B, C, A. So these positions have been changed, like these 3 positions have been changed, right? If these 3 positions have been changed, I know that this will contribute to a different string because like either I can apply operation on this or on this. But even if I apply operation on this part, still this character is being changed. And if I apply operation on this part, still this character like couldn't be changed in this operation. So a combination of 3 different characters will always result in a distinct string. Like if I apply cyclic operation on this, it will always result in a distinct new string. Is it making sense? And if the characters are same, A, then I will count, and I have a B here. So if I have this once, this will simply, like if I apply cyclic operation on here, I'll get S, string S, original string. Like you cannot, otherwise you cannot consider original string as one of the possible distinct values. Why? Because you have to apply operation once. But if you get AAA, you will have the original string also as one of the distinct strings, but don't consider it again for BBB. Like if you have three characters same, you can consider the original string once as your distinct string that you'll get. In this, I'm saying that if all are different, then you'll always get a distinct string. Why? Because there is no way that applying operation somewhere else, you can change all these three positions simultaneously. Is it clear? For all three distinct characters, like for all three different characters, you'll get a distinct string. And if the characters are same, you can consider the original string once. Now there are two characters here. Like either you can have something like, what can be there? Either this, like either this, or if we consider this thing. So after one move, let's say we have A, B, A, we get B, A, A. For this, if we have A, A, B, after one move, we'll get. And for this, if we have B, A, A, we will get A, A, B. Basically, I'm shifting these one cyclic. So let's consider, like this is the easiest. So in this position and this position has changed, right? Like the characters at these places have changed, right? Like these are a part of a bigger string. I had B here, A here, A here. I selected this as my operation. Like on these places, I'll apply operation and I'll get A, A, B. So my characters at these places have changed, right? Yes, no? Yes, anything? Okay, so now the thing is that this is also always a unique string. Why? Because you can apply operations anywhere else and you cannot change both of these characters simultaneously. Either you'll change just this or this, but you cannot change both of these positions simultaneously other than selecting this as your operation. And if you cannot select these two simultaneously, you cannot get like the characters changed here simultaneously. So that's why for this thing, if you have this kind of operation, then your answer is always like you can add one to your distinct strings. Now for these two, let's look at what happens in these two. If you have A, A, B, in one move you'll get, and if you have, you'll get. So if I look at in this, these two positions have changed. In these two places have changed. So simply saying that if you combine these two, like this can happen, right? If you have this string and you selected this, and let's say it was AB. Since only these two places will change, it is quite possible that you can also change that these two places in case you have a string like this, like in this operation. So in that case, you don't consider, like you cannot consider the result of both of these as a, like both of these don't give you different string, they give you same only. If you have A, B, A here. So if you have, like, if you look at this, the both of these operations will give you the same string. Let me show you how. So if you have A, B, A, let's say there's X here, Y here. If I apply this operation, you'll get X, shift this here, and this here. So you'll get A, B, A, Y. Now apply operation on this, let's say. So shift this here, and this here. So you'll get again X, A, B, A, Y. So these are same, right? So this kind of operation, like if you have this A, B, A, like these two are same, something different, and again same. So the two operations here will give you the same string. Is it clear? Yes, no? So what you can do initially, let's say you can consider that your complete, like you'll get all n minus 2 different strings, and then just you can see that if you're getting AAA even once, you can decrease, like for all the occurrences of AAA, like all these strings that you're getting same, just keep decreasing your, like initially your answer is this, and just keep decreasing your answer for these occurrences that all three characters are same. And if, by the way, if you get this thing, like even once you're getting three characters same, just maintain a check that yes, you have this. If check is 1, you can add 1 to your answer. Otherwise, check is 0. Check is basically that yes, you have AA. This is basically that you can get the original string as a one of the distinct strings. Otherwise, subtract 1 from your answer if you have something like AA, like some string, same character, some different character and the same character. Like I have already explained this case here. Is it clear for these? Just check this and subtract 1 from your answer, because this operation and this operation will result in the same string. Otherwise, we have already checked that we get a different string for this also, like this kind of also, and when all the three characters are different. Is it clear? We are taking check because if there are three same characters, then the original string is also possible as one of the distinct strings. But the original string doesn't mean like if there is a AAA here and later on we get a BBB. So we need to consider the original string just once. So check, if check is 1, that means the original string is possible. Otherwise, the original string is not possible. So just once. Okay, I'll like look at other, like if you have a different implementation, then we can look at that after the session. So let me show you the implementation. So this is the implementation. Initially, answer is n minus 2. Then I'm iterating through my string. I'm checking that the first thing is if the I and I plus 1 are same, I plus 1 and I plus 2 are not same, and I plus 1 and I plus 3 are same. So this is basically the case when I have star star and some different character and then star same. So for this, I decrease my answer by 1. Otherwise, if the three characters are same, that is, this is for the case that when I have something as star star star. So I'll decrease my answer by 1, and this means that the original string is possible. Finally, I can print the answer plus check. Is it clear? Yes, no? What about others? Okay, so let's go to the next problem. So in this problem, we're given that there's an undirected tree of n nodes and n minus 1 edges, and each node is either colored red or blue. And then we define two sets as S1 and S2. S1 is basically the distance of every node, every possible pair UV, such that U is less than V. And S2 is the distance between nodes U and V, such that U is less than V and the color of these two nodes is different. So finally, S1 and S2 are sets and they only contain distinct elements. And we call set, like we call the coloring good if S1 is equals to S2. Now, let's call CR and CB. Let's say that these two denote the number of nodes that are colored in red and blue. So given an undirected tree with n nodes and n minus 1 edges, finding a good coloring of the tree like we need to find a good coloring of the tree such that the values of this absolute value of CR minus CB is minimized. Like the difference between the number of red colored nodes and the number of blue colored nodes should be minimized. So if there are like multiple answers, we can print any. So basically, like first of all, let's try to understand the problem. Let's say this is 1, 2. So set 1 will have the distance, let's call it as D only, distance between 1, 2, and distance between, like this is the set, distance between 1, 2, 1, 3, all the way up till distance 1, 6. Then distance between 2, 3. Distance between 2, 4, all the way up till distance of 1, 6, 2, 6. And let's color these nodes. Okay, we'll color them later. Then distance 3, 4, all the way up till distance 3, 6. And distance 4, 5, distance 4, 6, and distance 5, 6. So set 1 is having all the possible pairs UV such that U is less than V. Now let's color this. Let's say that this node is blue. This is 1, this is blue, and this is blue. And the remaining are red. So this is 1, this is 4, and this is 3. These are blue and the remaining are red. So now, give me a second. Okay, where is it? So now my S2 will be the distance between node 1 and 2. Why? Because one is blue and the second one is red. Distance between 1 and 5 and distance between 1 and 6. Still U is less than V, but now the color of U is not equal to color of V. Then distance between 1 and not 1, 2 and 4, 2 and 3. Right? Because 2 is red and 2 is red and 4 is blue, 2 is red, 3 is blue. So similarly, for 3 also we can do. How is color of U and V same? So distance of 3 with distance of 3 can be considered with 5 and 6. So 3, 5 and 3, 6. So this is another set, like set 2, 3, 6. Then distance of 4 will be considered with 5, 4, 5 and 4, 6. And finally 5 will be considered with nothing. Like you cannot consider 5 with 6 because they have the same color. And 5 can be considered with 6 only because 5 is just less than 6. So this is another set. So we want, and these are sets. Like you might think that the size of this set is more than this set. No, we will consider only distinct values. So we need these two to be equal. So like we need to have every possible distance with just like nodes that are having different colors, like seeing the distance between those nodes which are having different color. So if we look at this, basically, you know what will this give us? This will give us, like if I'm just considering this will give me the distance between these two. This is my 1, 2, 3, 4. There will be 4. And after that, I can just simply write like this is the maximum distance possible between any two nodes. I'll get 3, 2, and 1. I can directly say this. Just find the maximum distance between two nodes. Like any two nodes, what is the maximum distance? And from that, you can just, if it is x, you can write x minus 1, x minus 2, all the way up till 1. Because there will be some nodes between these also, right? So you'll get all the distances. Like S1 will always be the maximum distance between two nodes from that till 1, or from 1 to maximum distance between two nodes. Is that making sense? Like S1 is always this set. Like, can you tell me like what is the doubt that here? Yes, basically this is the diameter. Like you have any tree, any kind of tree. So you just look at the two nodes which are farthest apart. This will give you the diameter. Diameter for this diameter is nothing but the maximum distance between any two nodes of the tree. So 1, 2, 3, 4, 5. 5. And I'm saying S1 will always be 1, 2, 3, 4, 5. Why? 5 you are getting between these two. 4 you will get from this, between this and this. 3 you will get from this to this. 2 you'll get from this to this. 1 you'll get from this to this. Like others you can also consider, but this is the finally this is the set that you'll get S1. Is it clear now? So from 1 to diameter. Is it clear? S1 will always be this only. Okay. So now this is what you want your S2 to be. So basically, let's consider this tree only. So if your diameter, if your D is the diameter and you want S2 to have D, you want two nodes which are D distant apart to be different colored. So basically this means this should be red and this should be blue. Is it making sense? Yes, no? Like this is for sure. Now, this is your diameter. Let me color it. This is your diameter. Now, what you can do, one way to solve this problem is that just have B, all the other should be B. Like, or let's say, like, just have one endpoint as that, and after that, this is your diameter. All can be red. So, like from this node, you're getting 1, till this node, you're getting 2, till here 3, 4, 5. So you're getting 1 to 5, right? So this is one of the ways, but the thing is, even though you're getting S1 as S2, you are not getting, like, this is not ensuring that color of, like, the number of nodes which have color as red minus the difference between the number of nodes which are color red and blue is minimized. This is not guaranteed. So to guarantee this, what we can do in our diameter, color half of the nodes as red and half of the nodes as blue. Why this always works, let me explain. You are getting, see, if you consider from this node, you are getting these distances. Like this is, let's say D, you're getting D, right? D. All the way, like, let's consider that there are K number of red nodes and remaining D minus K blue nodes in your diameter. So if you look from this node, first red node, you're getting, so 1, 2, 3, K. Or from K plus 1 to D, you're getting the distances, right? If you consider the first red node. And if you consider the first blue node, like the blue node which is adjacent to the red node, you're getting 1, 2, and K, all the way up to K. So from first, this is the first red node. From this red node, if you look at the blue nodes, you'll get distances from K plus 1, K plus 2, all the way up till D. And from blue node, from this blue node, you'll be getting all the distances from 1, 2, all the way up till K. So you are getting all the distances. in this arrangement that half of the nodes in the diameter are colored red and half of the nodes that are in diameter are colored blue. Other than that, for the remaining nodes, just do alternate. That half should be red, doesn't matter which half you're choosing, and half should be blue. So this is the solution. Like now it's just to find the diameter. Then we can color. So I know like if you're not aware how to find diameter, this is your first first week with us. Don't worry, like all of these things will be taught. Then like you'll have a better like idea on how to approach these problems. Like how do you get these distance? Like this is the guarantee that from this red node you can look that in the blue nodes, like the first blue node will be at k plus 1 distance because there are k red nodes. So k plus 1 till d, and from this blue node you can see that the first there are k nodes, right? So this red node is at 1 distance, 2 distance, all the way up till k. So from 1 to k and from k plus 1 to d, and others can be anything. So let me show you the implementation. So this is the implementation. In this, I have first taken the tree as input. Then I am creating my tree like this. Now this is my distance vector and this is my previous. Previous is basically to find the path from like path of the diameter, to find the nodes in the diameter. So this is the DFS that is being used. Now how I have found the diameter? I've used the property that the endpoints of the diameter nodes are always like farthest from every node. Like if you calculate the distance from every node, like for every node, the farthest node is one of the endpoints of the diameter. This is true over every node. Like you can check for this node, what is the farthest node? Either it will be this node or this node. So like there is no other node farther than the endpoints of diameter for any node in the tree. So using that, I have started, let's say, start from any node. I have started from 0. That is like taking the nodes starting from 0. So I've started from 0. This is my parent node. So I've just applied a simple DFS and I've calculated distances. Then I'm finding this is the one of the endpoints of the diameter. I'm finding the farthest node. Now from that node, I'm again applying DFS. So that will give me y. Now x to y. X is one of the endpoints of the diameter. Y is another endpoint of the diameter. So you can use any method to find the diameter. I've used this method. There are other methods also. So x to y is a diameter. Now in previous, I already have like what is previous of like y. It will be like I've started my DFS. Let's say this was my tree. This is my x, this is my y. So in previous, like when I do DFS, from x I will go to this node, then to this node, then to this node, this node, this node, this node, this node, and this node. So previous of this node will be pointing to this node. Previous of this node is this node. Previous of this node is this node. Previous of this node is this node. Basically to track back to x from y. So I have like this is the distance of y node from x and I'm taking half of it. So why I'm adding 1? Basically, if there is one edge, then like the distance is 1. But how many nodes are there? 2 nodes. So one should be red, one should be blue. So that's why distance plus 1 by 2. So this is the number of nodes that needs to be colored red and then the rest will be colored blue. So this is coloring the nodes which are present in diameter. Half of them are red, half of them are blue. Other than that, for the nodes which are not present in the diameter, initially in my answer, every character is this dot. For the diameter nodes, I have colored them either red or blue. If some node is not colored, it is not part of diameter. So just check that if the number of R is the number of nodes that are colored red. B is the number of nodes that are colored blue. If R is less than or equals to blue, color the current node as red. If otherwise, color the node as blue. Doesn't matter for the remaining nodes how you are coloring them, you just need to make them half. Finally, we can print our answer string. Any doubt? Okay, by the way, I'll share each and every solution. If you have some, like if you don't have doubts currently, but maybe you'll solve the problems on your own and you want to look at my solution, or you have some things to ask, or you have to refer to my solutions, I'll share those with you. Like you'll get the links. So that's it for today. And thanks for joining. Bye-bye.